Bridges. A bridge is a structure built to span physical obstacles such as a body of water, a valley, or road, for the purpose of providing passage over the obstacle. There are many different designs that all serve unique purpose and apply to different situations. Designs of bridges vary depending on the function of the bridge, the nature of the terrain where the bridge is constructed and anchored, the material used to make it, and the funds available to buy it. Depending on the type of structure, the bridges divide on suspension, cable-stayed bridge, arch bridge, beam bridge, truss bridge, cantilever bridge, and side arch bridge. Arch bridges use arch as a main structural component. Arch is always located below the bridge, never above it. They are made with one or more hangings, depending on what kind of load and stress forces they must endure. Beam bridges are very basic type of bridges that are supported by several beams of various shapes and size. The farther apart its piers, the weaker the beams becomes. This is why beam bridges rarely span more than 250 feet. Cable-stayed bridge, like suspension bridges, are held up by cables. On these bridges, less cable is required and the towers holding the cable are proportionally higher. Cantilever bridges are built using cantilevers that are horizontal beams supported on only one end. These are constructed using much the same materials and techniques as beam bridges. The suspension bridges are suspended from cables. The cables hang from towers that are attached to caissons or cover dams. Most suspension bridges have a truss system beneath the roadway to resist bending and twisting. Tied arch bridges are similar to arch bridges, but they transfer weight of the bridge and traffic load to the top chord that is connected to the bottom chord in bridge foundations. They are often called bowstring arches or bowstring bridges. Truss bridges is a bridge whose load-bearing superstructure is composed of a truss, a structure of connected elements forming triangular units. The connected element, typically straight, may be stressed from tension, compression, or sometimes both in response to dynamic loads. Ponte Vecchio, or Old Bridge, is the oldest of Florence's six bridges. It is one of the city's best known images, probably going back to Roman times, with its stone pillars and wooden planks. It was built in stone, but then newly destroyed by a flood in 1333. It was built again 12 years later, perhaps by Giorgio Vasari. The five arcades became three, and the main part was widened. The shops housed under the porticos first belonged to the commune, which then rented them out. But later, towards the 15th century, they were sold to private owners and began to charge through subsequent additions, raised bars, and external terraces, extending towards the river and altering the original architecture in an anarchical, suggestive way. In the 5th century, these shops were greengrocers, butchers, fishmongers, but then, perhaps because of their bad smell, Ferdinando I replaced them with goldsmiths, making the road more elegant and cleaner. This bridge had the advantage that it's used as a touristic event and it's used to pass across the river. And the disadvantage, I think, is that the structure may be compromised by the amount of weight that the bridge has. In 1565, Cosimo Fils de' Medici, Duke of Florence, had the famous corridor built by Vasari on the upper side passing over the shops. There is a curious story about that. The Manelli family, who owned a medieval tower at the southern end towards Pitti Palace, did not want to give the Duke right of passage, so the corridor had to be deviated, as we can still see today around the tower. The row of shops is interrupted in the center, and the bridge opens the Arno with two splendid panoramic terraces. Here in 1900, they put the bust of Venuto Cellini, that ingenious Florentine goldsmith and sculptor.